All right, section 2.2, excuse me, 2.3 and 2.4. Is that correct? Is that what we're on this week? Yes. Here's the main focus of these lessons. Slope. Tell me what you know about slope. Whoa. Okay, that's better. Tell me what you know about slope. Y equals mx plus b. What does that have to do with slope? Of this equation, what is the slope? M, right? Here's the slope right here. This is the M. Do you know the formula for slope? Very good. Y2 minus Y1 over X2 minus X1. Now, you guys are in college algebra, so you need to know a different way to write this formula. That's really the same. Okay? You'll recognize it as soon as I write it down, but I need to show it to you so you've seen it before. Fair? M equals f of x2 minus f of x1 over x sub 2 minus x sub 1. Do you see how that's the same thing? But if you've never seen it before, might that throw you for a loop if suddenly you see it on an assignment? Yes, right? Okay. So, but you're okay with that, right? Okay, so slope. I know I've shown you this before, but I'm going to show it to you again, just in case. Okay? Here's Bob. Bob is going on a ski trip. You can tell because he's riding a ski lift, and he has his ski poles and his hat. Okay? How is he feeling about this day? He's very excited, isn't he? He's very excited that he's going skiing. Okay? When he gets to the top of the ski lift, he accidentally turns left instead of right. And when he turns left, it takes him to a black diamond. What do you know about skiing? Do you know anything about skiing? Black diamond means it's like super, super hard. Lots of moguls, lots of bumps, lots of turns, lots of trees. If you are not an experienced skier, it can also mean death. Maybe not really, but I don't know for sure. Okay, so it might mean death. So when he gets off at the top and he's accidentally on this black diamond, he's screaming. And he still has his hat on. Okay? But he's screaming because he's on a black diamond. How has his attitude changed? Dramatically, right? It's changed dramatically. Now he's scared to death. Okay? Now, as fate would have it, he makes it to the bottom. He's okay. But right at the bottom of the hill, it's a weird place to ski. Okay? Right at the bottom of the hill, there's this completely horizontal section. Where's he going? Nowhere, just like his face says. Oh, I forgot his hat. Okay? He's not going anywhere. There's no motion at all. Okay? And then suddenly, out of nowhere, this giant gust of wind blows him off the cliff. Oh my gosh, his leg even came off. Okay, his poles broke, his leg came... oh, you can't even see that. His poles broke, his leg came unattached from his body. Uh-oh, I forgot his hat. Yeah, he's dead. Yeah, he's dead. Okay? So, does this silly story tell us a story about slope? Yeah, let's go back to the beginning. And Bob, how's he feeling on this particular day? He's feeling very positive. So when we're rising from left to right, as x's are increasing and my graph is increasing, this has a positive slope. Okay? As x is increasing and y is decreasing, what kind of slope is this? Yeah, because remember he got off on the black diamond and he's screaming because he's terrified. And then what happens here? He's going nowhere, right? His slope is 0. Because he's not going anywhere. And then the giant gust of wind. A giant gust of wind! And now he's dead. So he is what? Just the same as his slope. Undefined. Okay? He is undefined. He's no longer alive. You okay with that? Positive slope rises from left to right. Negative slope falls from left to right. A horizontal line has a zero slope, and a vertical line has an undefined slope. Okay? So this thing right here would look like y equals mx plus b. The negative would be y equals negative mx plus b. Okay? This would look like what? What kind of equation would we have for a slope with a zero? It's crossing the y-axis, right? So y equals some number. We'll just say a c for constant. Okay? Well, if m is 0 and I put m in right here, wouldn't it be y equals b? Or the y-intercept? I said c right here, could have easily put b, right? We're just using it to stand for a constant number. And then what would an equation look like for this? If m is undefined, I can't just take it out because that would be same as 0, right? Is 0 and undefined the same thing? No, it's not, is it? Okay, so what kind of equation is this going to look like? X equals a constant. This is crossing the y-axis. Remember, if I have a coordinate plane like this, if I have a horizontal line like this one right here, see how it's crossing the y-axis? And this is telling us where it's crossing the y-axis. A vertical line is crossing which axis? The x-axis, right there, and that C is telling us where it's crossing. Does that help? Does that help you remember what we talked about last year when we talked about slope? Good. Okay. Some things you need to know. We already talked about slope-intercept form. Do you know any other formula or form that uses a slope in it? What about this one? Remember that form? At least you remember the name, point slope form. Y minus y1 equals m times x minus x1. Now, why doesn't this y and this x have a 2 like it does in the slope formula? Do we substitute anything in for this x and y when we're writing point slope form? No, we do not, do we? This is what we substitute in for, an x and a y, and then we substitute an m as well. Do you remember that? Yes? Good. Okay. Is there any other forms that we might use? Yes? What about this form? Standard form. Do you remember that? You remember what it is? Anybody? Does that look familiar to you at all? Good. Okay. Here's what I find interesting. In standard form, and we call this in high school and junior high, we call this standard form. Okay. In the college algebra book, they have what's called general form. Okay. And general form to them is ax plus by plus c equals 0. How closely are those related? Pretty darn close, right? Now, some of you might be bothered by the fact that they're both positive c. Are they required to both be positive there? Couldn't this c be a negative 2 and it would just be plus a negative 2 or minus 2? That would be okay, right? Okay? But I want you to know the difference between these. I don't think there's a big difference in them at all, right? Just in standard form, it equals the constant, and in general form, the constant's on the same side of the equal sign as the x and the y. Does that make sense? Either way, we could find the slope from either one of these, right? What if I said, here's standard form, find the slope? What would you have to do? Subtract ax from both sides. So by equals negative ax plus c. How would I get the y by itself? Good. Divide everything by b. We know that dividing everything by b, like the whole side by b, I'm dividing each individual part by b. So I get y equals negative a over bx plus c over b. So what is our slope in this particular case? Negative a over b is our slope. And what's this c over b? What's that called? Good. The y-intercept. Okay? Is it weird to talk about this stuff using letters instead of just numbers? No? Good. That makes me happy. Okay? Okay. I don't know why I put form. I'm sorry about that. Should be form. Let's talk about what you know about this. Parallel and perpendicular lines. Tell me what you know about slopes of parallel lines. Parallel lines have the same slope. So if I say y equals 2x plus 5, tell me a line that is parallel to this line. 2x plus 3? What else? Give me another one. 2x what? Plus 0? Yeah? That works. What about y equals 2x minus 4? Ooh, minus. Yeah, nobody cares about that, right? What we care about is that the slopes are the same, right? This y-intercept can be anything it wants. It's just how far above or below this line it is. You remember that? Now, what does that mean? Parallel, right? It's just a symbol for parallel. Now, usually you use it in geometry, but is it okay if I use it in here? Good. What about this? What's that mean? Good. Perpendicular lines have what? How are their slopes related? Do you remember? Opposite and opposite reciprocal slopes. Now you guys know what a stickler I am on vocabulary, right? A lot of times people will say they have negative reciprocal slopes. Except what if the slope is already negative? Wouldn't that be confusing? It would be, right? So we say opposite because we mean opposite sign, opposite reciprocal slopes. So if I say y equals 2x plus 5, tell me a line that is perpendicular to that. Tell me a line that's perpendicular to that. What is the opposite reciprocal slope of 2? Very good, negative 1/2. Reciprocal, we flip it over and it's 2 over 1, so it becomes 1 over 2. It's opposite sign of what we have here. What if I said, give me the opposite reciprocal slope of this line and tell me a new equation that is perpendicular to this line? What would you tell me? Opposite would make it positive. Reciprocal would make it, yep, 3 over 4. I'm just going to go ahead and put plus 4 because it doesn't matter, right? That's just where they cross, isn't it? Questions? You good with parallel and perpendicular lines? Okay, the one thing that you may not be familiar with in this section, get off of that. Seriously, okay, is, oh, well, I know you know this. What does rate of change mean? Yep. It means slope. So what if, excuse me, what if it gives you this equation? Can you find a slope of that equation? Can you find a slope of a parabola? No, you cannot, can you? It's a curve, okay? But what you can find is an average rate of change. So what if I said find the average rate of change between x1 at 4 and x2 at 9? What would be the average rate of change between those two values? Well, if we're finding slope, which is what we're finding, which is rate of change, couldn't we use the slope formula? We already wrote it down before, right? Either this one or this one, depending on what situation we're in. Most of us feel more comfortable with this because that's what we've always seen. But you're fine with this one, aren't you? Okay? So if I know x, couldn't I find y or find the value of the function? So if x is 4, what's y? Well, what's 4 squared? 16. If x is 9, what is y? What's 9 squared? 81. Okay. If I have 2 points, can I find the slope? y2 minus y1 over x2 minus x1. What's 81 minus 16? Pardon? 65. What is 9 minus 4? Why was that top one easier than that bottom one? You guys are crazy. So what is my average rate of change between these 2 points? What's 65 over 5? 13? Now, while it's not the slope, we should not call it m equals. It's the average rate of change. Okay? Now, we know that a parabola looks like this, right? And I said between 4 and 9. So there's a line that goes between these 2 points. It's not the parabola. It's a line that goes through the 2 points. When you take calculus or even pre-cal, you're going to talk about this line right here being called a secant line. S-E-C-A-N-T. It's a secant line. Okay? This secant line is what you just found the slope of. Okay? Does that make sense? So the average rate of change between these 2 points is the slope of this line that goes between those 2 points. Does that make sense or no? Yes? Good. Okay? I think that's the only thing that you may not know, like you may not have seen before. Mostly because we didn't talk about secant lines in Algebra 2. This is kind of one of those things that's heading in a new direction. Remember the thing we did last chapter when it was like f of x minus h or x plus h minus f of x over h? That's going toward calculus 2. You remember how we talked about that? Okay? So those are the things that you're going to have to know in this, these 2 sections about slope. If you have any questions, please feel free to ask.